here we are, 313. Beer's Law, Lambert Law. Beer-Lambert Law. So on Monday, when you come in, what you are going to do is you are going to create from a 0.2 molar solution. You're going to take that and you are going to dilute it down from this down to a variety of different concentrations so that you end up going through and it gets lighter and lighter and lighter as you proceed through there, okay, to the point where you get to the very end and it almost looks clear, okay? And then when you come back in on Tuesday, you're going to fill these cuvettes up and you're going to put them through a machine called a spectrophotometer. And this spectrophotometer then can measure light that's moving through the machine. So this is what that machine looks like. We use a program called Logger Pro. And it looks like this to collect data. Okay, so I'm going to go new so you can kind of see what this starts out as looking new. I'm going to try to hit new and go to a new. There we go. Okay, so this is what my spec machine looks like. It hooks directly into the computer. And when you start out, you have to calibrate your spectrophotometer. Okay. The first thing that you have to do is that when you turn it on, you have to let it warm up. And it takes about 90 seconds to warm up. And I don't know if you can see through here or not, but you can kind of see that there's a light that's on in there. That bulb is warming up. And what you do is you take these different, these are called cuvettes. You're going to put them in here and then push it down. And that allows the light to shine through one side to the next. And what it's going to do is it's going to try to detect the different particles in here because those particles are going to absorb some of that light if they're colored particles. Okay. Here's a pass for you. Okay, so when you put this in, it's got about 15 seconds more to warm up, and then it's going to ask me, and I have instructions on this. I've uploaded them to Google Classroom. You guys can kind of look through those and make sure that you know kind of what you're doing with that. But it's going to ask me now to put in a blank cuvette. So this is the blank. Right here's your pass. This is what the blank cuvette looks like. It has kind of a rough side, and then it has a clear side. And you need to make sure that there's no air bubbles down in here. If there are air bubbles, you got to kind of turn it and bring it back and, you know, play with it until you get all of those that air up at the top. Okay. You also need to make sure that there's no fingerprints on here. And we only use these Kim wipes to clean these cuvettes. Okay, so they're in a special box. They're a green box. They're specialized for dealing with like glasses or microscopes. You might use them for microscopes to clean like the slides or the lenses on the microscopes because they're not going to scratch the sides of these. Scratches are going to interfere with that light transmitting. Okay. If there's a scratch on this, it's not going to allow the light to go through, and that's going to be interpreted as having solute inside there. So that would be an issue. Air bubbles can cause problems. If you have like water spots on the outside, use some distilled water. Wet one of these, wipe it down, and then dry it. Okay? They're going to interfere otherwise with the transmission of the light. When you put this down in, then hold it by the rough sides. Make sure that you line it up so that the clear sides are where the light is going through. So the light's going to go through there. I've got my blank in here, and now I'm going to finish my calibration. And it's finished. So now it's all happy. It knows that this is kind of its baseline. Okay. So that blank is filled with distilled water. And then you can just set that off to the side because you may need to recalibrate it the next day if you don't get all your data done. Okay. Then you're going to start out. You're going to put in your first amount, and that's going to be your stock solution. That's your 0.2 molar. And I don't know if you can see from where you're at, but there is a tiny little air bubble right here on the side. Okay. It's tiny, but I need to try to knock it out of there. And that did. And then you just kind of inspect it before you put it down in there. Again, rough sides, clear side. The clear side goes where the light goes through. So make sure that you have that in right. And I have all the instructions on for you. We're going to hit collect. And it's going to give you something like this. And then I hit stop. And what you'll do then is you're going to click this where we're going to configure it, and we're going to tell it absorbance versus concentration, and it's going to make us pick a point on here. And I tell you where to pick that on this line. You want the optimal line area for that, and we're going to talk about that when we get into the notes today, why I picked that spot. And then you'll hit OK. And then do you want to store it? And yes, we do. And then what you'll do then is you're going to take that 0.2 and we are going to collect again. We're going to collect down in this graph area and keep. And I'm going to tell it what molarity that is and hit OK. And then I'm going to hit stop. And then I switch that out and I put my next sample in. And this one has a bunch of air bubbles. I don't know if I'm allowed or not in time for us to be able to talk about this, but I'll probably just put it in there because it's going to give us close enough for what I'm talking about for you guys. But you need to try to get those out. I'm going to hit collect. I'm going to hit append to latest. It's going to shine the light through there. And now it's going to give me my concentration based on that. Okay, and you can see that it went down. And that concentration is actually 0.15. It showed up right here. So we have to tell it when we hit keep what concentration it is. So it's going to move that triangle over to here. And then we can keep doing that until we get all of our data. So if I want to take this one out, and let's say that I put in the 0.05. Collect, append to latest, keep 0.05. Okay, and that's going to give me here. And what I can do is I can take this data then and I can do a straight line on that to a best fit line. Okay. And then if I have an unknown, let's say that I put an unknown in there and it gives me an absorbance of 0.317, I can go along this line until I find 0.3, what did I say? 0.317, I think is what I said, 0.317. I can find that spot on this line. And then from there, I can tell what the concentration is. You can see down in the corner there that I have the XY values moving around. And when I hit the 0.37, it tells me, oh, okay, here's your concentration. And so then that'll tell me the concentration is 0.0774 molar. Okay. So the first thing that you're going to do when you come in is on Monday, you're actually going to be creating your serial dilutions. So you're going to create these. I've made up a 0.2 molar, and then you have to dilute them down until you get all of these other molarities made. And then the next day when you come in, you're going to do this part of that with the spectrophotometers. So when we look at this, like I said, we've got a light source, we have our cuvette in there, and then we have a digital detection out here. And that can tell us our molarities. You can also use kind of a eyeball method too, because you can see that these change colors as we change from one molarity to the next. And those can tell you the different moles of solute. You know, it can give you kind of a ballpark in there. When you're looking for the primary absorbance that you want to pick, you're going to look at a wavelength that is there, and you're going to pick the highest peak on that. If you were given this data and they wanted to know what wavelength you would want to select, you would look across here and find the highest peak, and that wavelength here will be 610. And then they give you a chart like this. They wouldn't make you memorize it. And you'd look for 610 on here, and you go, oh, that's orange light. And that's what would be the best choice for that to work with, okay? So different colors absorb different wavelengths of light. So if we have a red solution, you want to choose a green light because that's going to be transmitted more. Like I said, we can graph that calibration curve along here, and then you can use that curve or that best fit line to try to figure out where, based on an absorbance, where that concentration falls. So again, here, if we had concentration unknown of an unknown solution, the absorbance was 0.34. You could find where that 0.34 was and go over to your best fit line. You can go down then, and then that's going to give you your concentration. So here, that would be like 3 times 10 to the negative 6 for the molarity. Yeah? Because it's 3 here, and then the units are times 10 to the negative 6. And then here, like I said, for the appropriate wavelength, you want to try to find the highest peak. And that's going to give you your wavelength that you want to work with. If we, like I said, that's an orange light. And so the light that's going to get absorbed is on the opposite side of the color wheel for that. So if orange light is here, then what's absorbed is going to be blue. So what I want you working on now is what I expect to have done by the time you come in here on Monday, okay? So on Monday, when you walk in, what I expect to have happen is you are going to start by working on, here we go. You're going to be working on this lab. Okay, this I have uploaded to Google Classroom for you to show you like what you're going to be working on and how you're going to be doing it. But I didn't print off these color copies because I can't afford to do that. So if you want to look at this information, you're going to have to pull that up on the computer. On here, though, this is what I printed out for you. So what I expect to have done by Monday is I expect this to be done, and I expect this column in this chart to be done by the time you walk in on Monday. By Wednesday, I expect to have the whole lab finished, hopefully by then. And then I want this pre-lab brought in. Now, there was an error on this pre-lab. You need to change this. This should say dioxide, not oxide. This is in your packet. It's right past 313, between 313 and your progress check. And it should say nitrogen dioxide. That's going to change the way that the equation balances. So if you don't change this to dioxide, you're not going to have the right answers for it. Okay? So that needs to be done by Wednesday. And then by Thursday, I need your progress check done. So if you want to work ahead, do any of that stuff. I also have videos on AP Classroom that they had released. If you want to go back and if you're weak in an area or something, you can go back and watch the AP Classroom videos as well. So today, for the rest of the time that you have, you got about 20 minutes. What I expect you to work on is I expect you to work on getting this procedure written up and then this part of the chart. You need to at least know how to do this part of the chart, at least one or two of these. Now this you don't need to fill in because it is your stock solution. So you don't really need that at all. Design, layout, trying to figure out how to fill that in. So it is your stock solution. Okay, so you're not really going to need an, you'll need a little bit, you'll need whatever you have for your little cuvette. That's all you need for that guy. So you don't have to make any of him up. Your volumetric flask that you're going to be working with is 25 mils. So you're trying to make 25 milliliters of each of these. Okay, you're starting with this as your beginning stuff. You need to know how much of each of those you're going to add to this to then fill the rest of the way up with water to dilute it down. So if you go back to your notes in, it was 3.7, in here, 3.7, it tells you how to do these dilutions. Okay, so work on that. If you got questions on how to do it, let me know. We can get through it.